Hi folks, we're going to take a look at number 16 from page 269. So here they give us a position function, and note that we're only interested in times from 0 to 8 seconds. All right, so part A is to determine the velocity and acceleration functions. Now we remember that the velocity is just the derivative of the position function. So nice easy polynomial. So derivative of 3x cubed is going to be 9, not x, but t, 9t squared minus 2 times 40.5, so that's 81t, and then plus derivative 162t is just going to be 162, since derivative t is just 1. Okay, and then the acceleration function is just the second derivative of the position function, or the derivative of the velocity. Okay, so now we're just going to take the derivative of this function here. So that's going to be 18 t minus 81. All right, and we can now move to B, where it asks when the object is stationary, when it's advancing, when it's retreating. Okay, so now this is a an object moving along a straight line. Okay, so we know that it's going to be stationary, in other words, at rest, when the velocity is equal to 0, because the position's not changing. Okay, now here they're saying when is it advancing, when is it retreating? Not the words we would have used, but here I think what we're going to be assuming is we're going to assume that advancing means moving in a positive direction, and retreating moving in a negative direction. All right, so in other words, if you're moving in a positive direction, your velocity is positive. If you're moving in a negative direction, your velocity is negative. Okay, so that's going to be our task here, is determine, first of all, where the velocity is equal to 0 to answer the first part. So we need v at t is equal to 0. So in other words, we need this function here equal to 0. So I'm going to hope that 162 is divisible by 9. I think it is. Okay, 18. Good, makes my life easier, because now here I can just factor out the 9, and we're left with t squared minus 9t plus 18 equal to 0. And this is going to be factorable with 6 and 3, so 9t minus 3 and t minus 6. Okay, and so here, of course, this happens when t is equal to 3 or t is equal to 6. Now, we're going to accept both answers because we're considering between 0 and 8. Had something been beyond 8, we wouldn't have accepted it as part of our solution set. So here we can say at t equals 3 seconds and at 6 seconds. Okay, now we want to determine when the velocity is positive or negative. Well, luckily, knowing where it's equal to 0 is going to be helpful for us. Okay, so I'm just going to use a little diagram here. So I'm going from 0 to 8. All right, and the x-intercepts occur at 3 and at 6. And of course, we know a function can only change sign, at least when it's a differentiable function like a polynomial, at the x-intercepts. Doesn't mean it has to change sign, but in this case here, the velocity is a quadratic function. So we know that, and it's a quadratic function opening upwards because the leading coefficient is greater than 0. So we know that this function behaves like this. So in other words, we'll use their language here. We'll say advancing occurs when the first derivative is equal to 0, when the velocity is, sorry, not equal to 0, but greater than 0. So we have 0 less than or equal to t, less than or equal, or just less than 3, because at 3 it's stationary. Okay, or we also have from 6 less than t, less than or equal to 8. Okay, and here again we assume that time in seconds, just so I don't have to write it every single time. All right, and for retreating, so in other words, moving in a negative direction, well, that's going to be where the first derivative is negative. So here we have 3 less than t less than 6, where t is in seconds. All right. So again, this is where we see how we can use the sign of a function or its derivative, or likely its second derivative, to determine information about objects moving in a straight line. All right, so let's let's go to C. Okay, so C is saying at what time t is the velocity not changing? Okay, so now we need to know when the velocity isn't changing. So that's going to be when its derivative, in other words, the acceleration, is equal to 0. So what we're solving in C is we're solving A at t equal to 0. So in other words, here, 18t, might as well do some factoring here. Well, actually, it's just a linear. I don't need to do that. So 18t minus 81 equals 0. So let's solve. What is 81 divided by 18? So 81 divided by 18 is 4.5. Probably could have done that in our heads. Okay, and there you go at 4.5 seconds. Okay, now when we look at D and E, it says when is the velocity decreasing? When is the velocity increasing? Okay, so in other words, we're going to be using now its derivative again to determine when it's increasing or decreasing. Okay, in the part B, we use the velocity to determine when the position was increasing or decreasing. Okay, so we remember that the sign of the derivative tells us whether the original function is increasing or decreasing. So for D, we're looking for decreasing first. Well, again, I'm going to do what I did before, is consider only the times of interest from 0 to 8. And when I look at my acceleration function, I see that it's a linear function. We know its x-intercept at 4.5. And since it has a positive slope, it's going to be a linear function like this. Okay, so in D, we're looking for decreasing. So that's when the derivative is negative, or in this case here, the acceleration, the derivative of the velocity is negative. So for D, it's going to be 0 less than or equal to t less than 4.5 seconds. Okay, and then in E, when we want to know when the velocity is increasing, well, that's when its derivative, or the acceleration, is positive. Okay, so this is going to be 0 less than, positive, so 4.5 less than t less than or equal to 8, again, t in seconds. All right, so just to recap, when you're given the position of an object with respect to time, okay, velocity and acceleration are given by the derivative and second derivative, and you can often use the sign of these three functions to determine information about how the object is moving, and very often when these three functions are equal to 0 also gives you some information, and these are just some of the many pieces of information you can get using that information. Okay, that's it for this one.